Hey, ladies and gentlemen, welcome to lesson 3.5. This is arithmetic sequences. The big goal of today is that at the end of the lesson, you can say, I can make an equation for the nth term. Leave it at that. So sequences. Sequences are just a set of numbers that are in a specific order. An arithmetic sequence is one that increases or decreases at a constant rate. So we're looking at the words increase or decrease, which means that things are going to be adding every single time by the same number or subtracting every single time by the same number. So this one, our constant rate, and we're going to call our constant rate D, is a plus 2. And on the next one, our constant rate, see that they're going down by 4 every single time. Our constant rate D is a negative 4. So part of our process today is to say, hey, look at these numbers. If they are following the pattern of having a constant rate for all of the digits or all of the numbers in the sequence, then it's arithmetic. If it's not for all of them, then it's not. So on our very first examples, our question is, are these arithmetic sequences? So a negative 15 to a negative 13 to a negative 11 to a negative 9. We are increasing by 2 every single time, so this is a yes. So I believe your assignment will ask you if it is a yes or a no, say what it is, and it might even say, well, what are the next 3? The next 3 would be a negative 7, a negative 5, and then a negative 3. Now, ooh, that was pretty ugly. What's going on there? We'll hit undo. It gets away with everything. All right, so the next one is where you guys get all freaked out and stuff. It's a fraction. I understand that. But they all have a common denominator, so that's exciting. All we got to do is look at the numerators then, because the denominators will help us out. So we went minus 2, and then minus 4, and then minus 6. Now, even though this is a pattern, this is not making us follow the simple rules of it being in adding the same thing or subtracting the same thing every single time. So this is a no. This is not an arithmetic sequence. It's something else. We'll talk about it later, maybe in some other chapter. All right, let's move on. Here's where kids get confused. So make sure you write down this formula. This is a little algorithm to help us determine the nth number in a sequence. So what we're going to do here is we're going to use this information. So a sub n means that we're looking for the nth term. A sub n is just the first term in the sequence. N is the number that we're going to end up looking for. So it's going to make an equation that follows a rule for all of the numbers in the sequence. And then D, like I already described before, is going to be our common difference. So let's check it out. So here's our first sequence. We're going to use the formula to be able to create an equation for the nth term. So I'm going to move this up a little bit. Wee. The first one seemed a lot more exciting than the second wee. All right, so the formula will continue to look the same. The a sub 1 is the first term, so that's this one right here, the 1. Then we're going to do plus, and then in parentheses, the n minus 1 stays the same. And then our common difference is that we went up by 9 every single time. So we're going to multiply that stuff by a 9. Now to make this work out, we're going to have to distribute. So this turns into a 9n, because 9 times n, and then a negative 9. And then we have this plus 1 over here. And that's going to be equal to our a sub n. So this tells us whatever term that we're looking for. In this case, it's going to be the 12th one. Now the last step is to simplify. So we're going to combine our like terms that we have. And you're going to notice that we have a nice, beautiful formula here. I'm going to put my variable first. So it's going to say 9n minus 8. So we have a multiply by 9 and a subtract 8. So if I put in the first term, put in a 1 here, 9 times 1 minus 8 gave me this 1. If I put in a 2 for the second term, 9 times 2 minus 8 made us the 10. So now what we're going to do is we're going to find the 12th one. So we're going to plug the number 12 into here. So here's how it looks. A sub n is equal to a 9 times 12 minus 8. Now my calculator is going to do my math for me. 9 times 12, because 108 is difficult to do without a calculator. 9 times 12. I still got 108. Good thing that my brain works. So 108 minus 8. So my 12th term is equal to 100. And that's this process here, folks. We're just plugging the numbers into the formula, and then we're going to simplify the formula and work from there. Not too shabby. All right, let's move on to another one. So here's a beautiful word problem example. So here's our sequence. Here's our first number, the second number, the third number, the fourth number in the sequence. Our job is to write a function. Here is the function rules that we're going to follow. So we're going to have a sub n is equal to the first number in our sequence, which is a 12, plus the n minus 1, and then we need to figure out what our common difference is. So notice that it's going up by 11. So we're going to multiply by 11. So if we distribute this to the stuff inside the parentheses, we're going to get an 11n minus 11, and we're going to add that to the 12 that was already in there as it's the first term. So our a sub n, we're going to combine our like terms, Christmas colors, unintended. And we find out that we have a sub n is equal to, on the third line it's going all glitchy again. Catch up, computer. Here we are. So it's going to say 11n is equal to an 11n and then plus 1. So if we were to graph that, we would plug these numbers in. So check this out. We have the first number, the second number, the third number, the fourth number. If we were to graph those things, the very first number was a 12. I had to go back and check. I have a bad memory. I'm getting old. So I'll go to the right 12 and up 1, or right 1 and up 12. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we are with the first number. So let's just pretend that these all went up at the same slope. A slope is going to be our 11, and it has a y-intercept of 1. So I've graphed that incorrectly. Let's get rid of it. I'm going to start over. So it starts up here at 1, and then have a slope at 11. So we're going to go up 11. Our domain is the x values. So the x values are going to be all real numbers. They're going to be any number that you can choose will be able to work for us. We'll talk more about this graphing step here when we get back to class, folks, because that takes a little bit more time. And I'd like to have a better graph to start off on. All right, so this is the Bermination. I'm signing off. This is what your assignment's going to be for you, folks. And we'll catch you on the flip side. Peace out.